Welcome to Math on Ice, December 2015 Integral Equations. There are 3 questions, 1 question from part B and 2 questions from part C. The first question, the resolvent kernel R of x comma t comma lambda for the Volterra integral equation. So the formula for resolvent kernel R of x comma t comma lambda is equal to summation n is equal to 0 to infinity lambda power n into k n plus 1 of x comma t, where this k n plus 1 of x comma t is equal to integral t to x, as it is a Volterra type, integral t to x, k of x comma z into k n of z comma t into dz, right? So when it is a Fredholm integral type, we will have the limit, whatever the limit is given in the question, we will take that limit. Okay, now k of x comma t is equal to k1 of x comma t, which is equal to 1 here. Kernel is 1 here. K2 of x comma t is equal to integral t to x, k of x comma z into k1 of z comma t into dz, which is equal to integral t to x, k of x comma z, which is equal to 1, and this is also equal to 1, and dz, which is equal to z t to x, it is x minus t. Now k3 of x comma t is equal to integral t to x, k of x comma z into k2 of z comma t into dz, which is equal to integral t to x 1 into z minus t into dz. So this is equal to, when you take the integration, it will be equal to z minus t the whole square divided by 2. Apply the limits tx. So we get x minus t the whole square divided by 2. Now again, when you solve, k4 of x comma t will be equal to integral t to x, again 1 into z minus t the whole squared by 2 into dz, and this here will be t to x, z will take the limit. So this is equal to z minus t the whole cube by 3 into 2, which is equal to 6, and then the lower and the upper limit, which is equal to x minus t the whole cube divided by 3 factorial. So we can consider the general case. K3 is equal to x minus 2 the whole square divided by, you can take it as 2 factorial. And this kn of x comma t will be equal to x minus t the whole power. When there is 4, we get 3 power, and in the denominator we get 3 factorial. So when there is 3 here, we get 2 here. So when there is n here, it will be n minus 1 divided by n minus 1 factorial. So kn plus 1 of x comma t will be equal to x minus t the whole power n divided by n factorial. Now what is the formula for resolvent kernel, which is equal to lambda power n? What is lambda here? Lambda as it is lambda, no change. Kn plus 1 of x comma t, we need to find the series summation. So r of x comma t comma lambda is equal to summation n is equal to 0 to infinity lambda power n into x minus t the whole power n divided by n factorial, which is equal to summation n is equal to 0 to infinity x minus t into lambda the whole power n divided by n factorial. So what is the formula of this one? This is actually, when you take this full part, I'm going to take x minus t the whole lambda, which is equal to, if I take it as u, what will happen? This will become summation n is equal to 0 to infinity u power n divided by n factorial. What is this actually? This is equal to e to the power u, right? So a exponential series is written like this. So e power u, when you have it, is u 1 plus u power 1 by 1 factorial, u power 2 by 2 factorial, and so on it goes, where u is equal to x minus t into lambda. So we have this full thing is equal to e to the power x minus t into lambda. X minus t into lambda. E to the power x minus t into lambda is the answer. So here e to the power x minus t into lambda. Second option is the right option. Next question from part C. Y is a continuously differentiable function, and they have given the integral equation and then 4 options. This is somewhat similar to the problem which was asked in the year June 2014. Okay, so we'll take the function y of t here. So y of t is equal to y of 0 plus integral 0 to t y of s into ds. Now take the direct squaring, y of t the whole square, that is y squared of t, and then square this right hand side also by using the formula a plus b the whole square. So we get a squared and then b squared and then plus 2ab, right? So this is what given in your last option. So this option is true. Y squared of 0, yes it is here, and integral 0 to t y of s ds the whole square, yes it is here, and 2 times of y of 0 into integral 0 to t y of s into ds, yes, and this is true. Next, we are going to solve the problem with a hint. Continuously differentiable is given, right? So we'll just differentiate and evaluate what is the value of y, and we will just get the solution and verify each option by option. Now y of t is equal to y of 0 plus integral 0 to t y of s into ds is given. Take y dash of t. I'm going to differentiate with respect to t. Okay, and this is based upon the Leibnitz rule of integration, differentiation. Here y of 0 is a constant, so when you differentiate a constant, this will become 0 plus d by dt of integral 0 to t into y of s ds, that is equal to integral 0 to t. Taking differentiation inside the integration will become this way. This is called Leibniz rule, dou by dou t into y of s ds plus differentiation of your upper limit and then applying whatever. Here in the place of s we have to substitute t, y of t, and then the differentiation of lower limit will become 0 minus the lower limit is 0. The differentiation of the lower limit is 0, so we get 0 here. And then y dash of t is equal to this part. This y of s is independent of t, right? So this will become 0 and only left over is here dt by dt, which is equal to 1. So y of t, y dash of t is equal to y of t, that is y dash is equal to y. So we get dy by dt is equal to y. Now this implies dy by y is equal to dt. This is equal to log y is equal to t plus some c. We have log of y of t is equal to t plus 0. Okay. When I put t is equal to 0, what happens here? Log of y of 0 is equal to 0 plus c. So that implies c is equal to log of y of 0. Right. So I have log of y of t is equal to t plus log of y of 0. Log of y of 0. Right. So I'm going to bring this log of y of 0 to the left side. So I'll have log of y of t minus log of y of 0 is equal to t. So I get log of y of t divided by y of 0 is equal to t. So that implies when I take exponential, when I rise to the power e, I get y of t by y of 0 is equal to t. So I get y of t is equal to y of 0 into e to the power t. This is what the solution. Y of t is equal to y of 0 into e to the power t. Now we'll go by option by option. In the first option, y squared of t is equal to y squared of 0 plus 0 to t, y squared of s into ds is given, right? So first we will evaluate what is your y squared of t is here. It is equal to y squared of 0 e to the power 2t. We need to get this one. So the first option is given by, first option is giving you y squared of t is equal to y squared of 0 plus integral 0 to t y squared of s ds. 0 to t y squared of s into ds. Let us take the RHS. Y squared of 0 plus integral 0 to t and y squared of s into ds, right? So what is your y squared of s here? Y squared of 0 e to the power 2s ds, which is equal to y squared of 0 plus y squared of 0 integral 0 to t e to the power 2s into ds, which is equal to y squared of 0 plus y squared of 0 e to the power 2s divided by 2, applying the limits. So we get this is equal to y squared of 0 plus y squared of 0 e to the power 2t minus e power, we get 2 outside, we'll take 2 outside by 2. In this part, e to the power 2s, that is e to the power 2t minus e power 0. So this is equal to y squared of 0 plus y squared of 0 by 2 into e to the power 2t minus 1. So you can also take out y squared of 0. You will be left with 1 plus e power 2t by 2 minus 1 by 2. So we get y squared of 0 into e to the power 2t by 2 plus 1 by 2. So this is equal to y squared of 0 e to the power 2t plus 1 divided by 2 is your y squared of t. But this is not exactly equal to this one. Okay, so the first option is wrong. Here when you see only 2 has been multiplied here. Now look at this option. Look at this option. This option has the 2 which is making us the trouble. So I'll have 2 here. So this will cancel it off and you'll get a solution. Here option 2 is y squared of t is equal to y squared of 0 plus 2 times of integral, what is the limit? 0 to t, right? Integral 0 to t, integral 0 to t y squared of s into ds. So I'll take the RHS, which is y squared of 0 plus 2 times of integral 0 to t y squared of 0 into e to the power 2s into ds. So that is equal to y squared of 0 plus 2 times of y squared of 0 integral 0 to t e to the power 2s ds, which implies y squared of 0 plus 2 into y squared of 0 e to the power 2s by 2 outside 0 to t. So this and this cancels each other. We get y squared of 0 plus y squared of 0 and this is e to the power 2t minus e power 0 is 1. So we get y squared of 0 plus y squared of 0 into e power 2t minus 1. When you take out y squared of 0 outside, we get 1 plus e power 2t minus 1. See here, 1 and 1 cancels each other. We get y squared of 0 into e to the power 2t. That is what we need, y squared of t. We got the right solution. This is what we need, right? So this is what we got. So this option is true. This second one is true. And the third option we will verify. It is simply given y of s. And for the third option, y squared of t is equal to integral 0 to t, wait, y squared of 0 plus integral 0 to t y of s into ds. So here we get the RHS as y squared of 0 plus integral 0 to t. Y of s is simply y of 0 into e to the power t into d into the power s into ds here. So that implies y squared of 0 plus y of 0 integral 0 to t e power s into ds, right? So that is equal to y squared of 0 plus y of 0. When you integrate it, you will get e to the power s again 0 to t, which is equal to y squared of 0 plus y of 0 into e to the power t minus e power 0 is 1. So this is actually y squared of t here, but this is not actually the same thing, right? So we get this is not equal to, and the first option y squared of t, this y squared of t is not equal to, this one is not similar here for the first option, and for this third option is also it is false. The second and the fourth options are the correct options. Moving on to the next question. This question is also from part C. Let lambda 1 and lambda 2 be the characteristic numbers of f1 and f2 be the corresponding eigenfunctions. Okay, this question is also somewhat similar. The options are similar based upon the questions asked in the year June 2014. So here, when you see the corresponding characteristic functions, that is eigenfunctions, the eigenfunctions with respect to two different eigenvalues will be orthogonal, right? So that will be orthogonal, so that would satisfy this condition. If lambda 1 and lambda 2 are not equal, if they are the characteristic numbers, that is eigenvalues, and f1 and f2 are the corresponding eigenfunctions, if they are not equal, if they are distinct, then obviously the functions will be orthogonal. Obviously this third option will be correct if this first option is true. If first option holds, then third option must hold. Okay, so here we will see phi of x is equal to lambda times of integral 0 to 1 2xt plus 4x squared into phi of t into dt. Now we need to verify lambda. We need to find lambda. How do we find lambda? We find by the matrix Ax is equal to b. Here b is not here because f of x is a homogeneous equation, so we get Ax is equal to 0, where the matrix A is equal to 1 minus lambda a11 and minus lambda a12 minus lambda a21 and then 1 minus lambda a22. As kernel k of x comma t is equal to 2xt plus 4x squared, alpha 1 is equal to 2x, beta 1 is equal to t, and then alpha 2 is equal to 4x squared, beta 2 is equal to 1. So we find a11 or as aij, which is equal to integral 0 to 1 here. So generally we write a to b, integral a to b, beta I of x into alpha j of x into dx. This is the formula. And this matrix x will be equal to C1, C2 matrix. Okay, so I'll solve one by one. We don't need this C1, C2 and all. We directly solve for lambda. Okay, a11 is equal to integral 0 to 1, beta 1 and alpha 1, which is t here. So it must be a function of, it must be converted to a function of x. So this will become x into 2x. You will have 2x squared into dx, which is equal to 2x cubed by 3. Lower and the upper limit, we get 2 by 3. And then a12, which is equal to integral 0 to 1, beta 1 and alpha 2. So we have 4x cubed into dx, which is equal to 4x power 4 by 4, 0 to 1. So we get it as 1. And then for a21, we get integral 0 to 1. a21 means beta 2 and alpha 1. Beta 2 is 1 here, alpha 1 is 2x. So we get 2x into dx. So this is equal to 2x squared by 2. Applying the limits, we get 1. And then a22, which is equal to integral 0 to 1, beta 2 and alpha 2. Beta 2 is 1 and alpha 2 is 4x squared into dx, which is equal to 4x cubed by 3. Applying the limits, we get 4 by 3. So here we got A matrix is equal to 1 minus lambda a11. What is your a11? 2 by 3. and minus lambda a12 which is equal to 1 and minus lambda a21 which is 1 and then 1 minus lambda 4 by 3. So this is equal to 1 a is equal to 1 minus 2 lambda by 3 minus lambda and 1 minus 4 lambda by 3. Now we will just find the determinant of the matrix, equate it to 0 to evaluate the values of lambda. Find the determinant of A which is equal to 1 minus 2 lambda by 3, 1 minus 4 lambda by 3 and then minus lambda squared is equal to 0. So 1 minus 4 lambda by 3 minus 2 lambda by 3 plus 4 2s are 8 by 3 3s are 9 lambda squared minus lambda squared is equal to 0. So here 1 minus 6 lambda by 3 plus 8 lambda squared minus 9 lambda squared by 9 is equal to 0. So cancelling these two we get to 1 minus 2 lambda plus lambda squared, okay, minus lambda squared by 9 minus lambda squared by 9 is equal to 0. Now taking LCM we get 9 minus 18 lambda minus lambda squared is equal to 0. That implies lambda squared plus 18 lambda minus 9 is equal to 0. When you multiply you get minus 9 and when you just add you get 18. Okay, it is bit difficult to find the solution. So we'll solve by b squared minus 4ac divided by, so this is minus b plus or minus root over b squared minus 4ac divided by 2a. So lambda is equal to minus 18 plus or minus root over 18 squared minus 4 into 1 into minus 9 divided by 2 into 1. Obviously, when you see here lambda is equal to minus 18 plus or minus root over 18 squared plus 9 4s are 36 divided by 2. This term b squared minus 4ac is not going to be 0. It is not going to be 0. If it is 0, then it will have repeated roots. And it is also positive, so it will not have imaginary roots also. So this is going to be greater than 0. If it b squared minus 4ac is greater than 0, we get real and distinct roots, right? So this implies lambda 1 is not equal to lambda 2. Without evaluating, we can say lambda 1 is not equal to lambda 2 means the eigenvalues are distinct. So the eigenfunctions will be orthogonal. So the first option is true and this third option is true. Orthogonal means integral 0 to 1 f1 of x into f2 of x into dx should be equal to 0. So these two answers are false. So first and third is the solution. Thank you.